Welcome to EDU World Space.
Alright, so we want to set up but not evaluate the integral expressions for mass, center of mass, moment of inertia, for the hemisphere, and this density function here. Okay, so for the mass, this is what the mass is defined as, and for the hemisphere, this is our E, right? E is just the hemisphere. Okay, so we can define a hemisphere like this. It's not too difficult. And now let's set up the integral. Okay, so from -1 to 1, from -1 minus square root of x squared, 1 minus square root of x squared, from 0 to 1 minus x squared minus y squared of the density function dz, dy, dx. All right, so that's the mass. So the mass is a triple integral. So that's the mass. Got it. So now the center of mass, well, the center of mass is defined in terms of x bar, y bar, and z bar. And the way we define the center of mass is we take this integral here and we divide it by mass. Okay. So it's really just a plug in the expressions, right? So our bounds for each one of these triple integrals is always going to be the same. The only thing that's changing between the x, y, and z is that we multiply the density function by these things respectively, x, y, and z. And then finally, we're dividing by m for each one. Okay, so those are the expressions there for center of mass. And then it asks us just to find the moment of inertia about the z-axis. Okay, so moment of inertia about the z-axis is given by this equation here, this triple integral. So again, the bounds are the same. Now, instead of multiplying by z, we multiply by x squared plus y squared times our density function, and we're done.